Hello friends, and welcome to my proof of concept, where I'm going to take 4 separate solar panels and connect them all to one battery with multiple controllers, and I'll show you how it works. Alright friends, quick unboxing of the InnoPower solar panel. This is probably the most highest quality solar panel I've found regarding to the amount of accessories they give. They give you nice high quality cables that fit every single kind of solar power station. The 5521, the XT60, the standard connector, and the Anderson, and these different adapter plugs for the 5521 to the larger and smaller barrels, to the 5525, and this one I don't know what it is. I like that this is covered up, and now let's continue to the proof of concept. Hey friends, and welcome to the proof of concept. I connected all the solar panels to that one battery bank using multiple charge controllers. This is also a test of the InnoPower 100-watt panel. So what we have is the InnoPower 100-watt panel there, the Powerwerx 120-watt panel. So two 120 watts and two 100 watts versus each other. Different locations. This is a late afternoon sun. It's very hazy, you know, with all the smoke coming from Canada. But basically put, this is the proof of concept. Let's say I wanted to charge up one battery bank. I'm able to put all the solar panels in one cart and use multiple controllers. Let me show you how fast it's charging. So let's see, based on the cables, this one goes to this one, the InnoPower. What is the InnoPower getting? We're getting 40 watts from the InnoPower, and you see it's charging up. Now the Powerwerx, we're getting 72 watts. That's pretty good. Now let's see this InnoPower on the right. We're getting no wattages. Is this connected correct? 4.6 amps. Right, that's weird. 18.95 volts. How is it saying it's charging? See, it says 14 volts, 4.5 amps. Oh. Okay. Sorry about that. I had to reconnect it. It was backwards. The load has to go to the where the battery is charging. So 11.8 watts. Let's check out that 120 watt panel. That's getting 16 watts. 60 watts there. 0 watts again there. But over here, we're getting 0 watts for some reason. So now we're trying to connect and re-disconnect because the proof of concept is not really working. Perhaps maybe it's the different voltages, the solar panels. Maybe I got one of these wirings incorrect, but we'll check it out. I'll try plugging it directly into the charge controller myself. I found the reason for this. It turns out this bank is completely charged up. So yeah. I gotta discharge it a little bit. Alright friends, it's the next day. This battery got drained, but it is a bit of a hazy day. But the idea of this test is to be a proof of concept that you can connect multiple solar charge controllers to your solar panels and have it all work all at once. So these are all connected. You see they're all charging. Like for example, this 120 watt is now generating 31 watts. This 100 watt is generating 13 or 12. This 100 watt over here is generating 25. Something might be blocking that one. And the one all up front is generating 12 watts. So This shows that you can have multiple controllers do this kind of setup. Now let's talk a little bit about it. Well, when you normally get a solar charge controller, basically a solar battery bank, a solar generator, you only have one input port. But what I'm advocating here is using 6 to have multiple inputs. I understand it's a hazy day, but if you think about like these solar panels, you might be able to get 60 to 80 watts out of them on a more solar day. Like for example, the sun got more intense. Let's see, we're getting 42 watts, 31, 31, and 17. And on this controller, we're getting a total of 116 watts coming in, a total of 10 amps. This is off because it was off before, but at least it's showing how much wattage is coming in. That's important. This shows that the system works. And in the previous video where it wasn't taking a charge, it's because the battery bank was completely full. So when it's full, the charging stops. So that might help with those people that might be fearful of something overcharging where it will charge continuously until it just doesn't charge anymore. One of the things to realize with these battery banks nowadays, the ones that are made, is that they have what's called a BMS, a battery management system. So how it works is a protection system. If the battery bank is charged up, it will stop charging it. If it's over discharging too fast, at let's say over 100 amps is rated for, it might stop the battery too. And some person might think that they have a dead battery, but the way you restart it is by connecting a charge controller like this one to it, and it should wake up the BMS inside it. You see over here, we have automotive fuses. So inside are what's called blade fuses. These are all set up for 40 amps, and that's the way cars are set up. What this is a combination of is watching a lot of YouTube videos and watching this guy. This I found out from people that do ham radio. They like to do this. This tape over here is special car tape. Inside Audi and Mercedes cars, for example, they tie up cables with this kind of cable. It's called Tesa tape, T-E-S-A. This kind of connector is very convenient to have because you can connect it and disconnect it. So the only thing that was separating this battery from being called a solar generator was the input ports. On a solar generator, usually you have one input port, and what you're gonna find is under 400 or 500 watts, they can only charge at max 100 watts an hour. 100 watts an hour is not enough, especially if you wanna connect multiple solar panels. But you see the situation with the ones that have a limit to the amount of charging that you have in there. 33, 27, and what's the total over here? 127. So it depends on the sun. You see the sun is very, very hazy. So the example being is that if you connected all of these solar panels in parallel to one solar generator, it would be limited by the 5 amps that the input port in that it has to input. But it depends on the unit, obviously, and you have to look on it, and also voltage open circuit. The example with this charge controller, the battery power, it can take up to 30 volts open circuit. What this means is that you could technically use this charge controller to charge this battery from a 24 volt bank or from perhaps a USB power or from a power brick. One of the things that you might notice though is that if you use only a 100-watt power brick, it might overamp it. Because the way that these charge controllers are designed, at least what I found with my Victron, is that it overamps it. For example, if I have a 70 amp controller and I connect, let's say 4 or 5 charger bricks, the Dell ones, it might overamp it, and those charging bricks, they don't want to do it because they see it as a short circuit. But the trick is to connect more of them, up to like even 8, to a 70 amp charge controller. But that's a different story. What we're talking about over here is the portability. And with this Anderson port and being universal, it's very convenient that, for example, that I can connect individual power bricks. But you see, we're seeing that each one of these solar panels is giving an individual amount of watts, and they all combine together inside the solar bank, the battery pack. But then, for example, if you're charging with 4, you could split this up, one connection, into 2. Let me explain how this wiring works. I usually like to at least maximum gauge or over gauge. Like for example, these fuses, these are 10 AWG, and 10 AWG wires can do up to 30 amps. And this connector, the Anderson one, the thicker one, they have a 45 amp, a 30 amp, and a 15 amp. So this connector could do even up to 45 amps. But the maximum size wire that could go into this cable, the 10 AWG cable, is 10 AW into the 45 amp or the standard Anderson plug. This one, this size, is up to 10 AWG. So that's why I used 10 AWG, and basically put this cable is rated up to 30 amps and this fuse is rated for 40, because you want your fuse to be rated a little bit higher than the maximum ampage of this. So the idea is that if there's a short circuit anywhere, the fuse would blow. But the way that the system design is actually pretty cool, because these battery powers actually have inside them over voltage, over current, over the different protections. Like for example, so the way that it's designed is that this also has protections built into it. The guys that designed this, so it's not gonna backfeed this, but I still like to have the fuse in there. The fuse is a very important thing. And the idea is, I grew up with computers, and I love the idea of having standard USB ports, everything standardized, and everything be able to plug into each other. And these Andersons are the game changer, because you could just standardize everything. You could have one connector connect into another connector. And one of the things with electronics, the biggest factor that I found is that you don't want to overvolt them. For example, if you have a solar generator that can do up to 24 volts open circuit, you look at the VOC, voltage open circuit, on the product page, and you see it says 24 volts, and you can connect to it. This is what I like about it, is that it could do up to 30 volts. But anyways, the point is this: most devices will only take the amount of amps, which is the amount of power that they can actually absorb or use, but you can't over voltage them, because over voltaging them might actually damage the unit. It's very, very easy. But still though, 47 watts, well, because there's 4 of them, that's a more efficient system, and you're not limited to it, because, for example, if one of these solar panels gets shaded, the other one gets the full output that it can to this. These charge controllers can do up to 135 watts, and we have a maximum 120 watt solar panel over there. So these are perfect for 100 volt solar panels. And I found this to be the best charge control in the market, because it's easy to cut these ends off and put the Anderson on. And it comes with SAE connectors. I'm looking at these SAE connectors, and they're They're the most retarded connector type I've ever seen, but I'm glad it's easy to cut off and that the Anderson connectors are easier to do. Thumb up the video and ask me to make an Anderson connector tutorial. I'd love to do it. That's one of the things in the future. And the reason what this is actually a shout out to one of the people that watched a battery review video that I did, that said, show me how this charge controller multiple charge controllers can connect to this and all combine into one. And this proof of concept shows that you could have a system that is 12 volts. 12 volts technically, if I understand it correct, it can't hurt anything. It can't hurt an animal, it can't hurt a cat, it can't hurt a dog. You could probably lick it all day and you still can't get hurt. But I don't recommend licking things like this, and especially if you follow precautions, safety precautions. You see this is all taped up, the terminal covers are covered up, because the only damage that you could do is that if you jump these two connectors, the plus to the minus, that creates infinite flow of ampage there, and the battery's probably going to smoke, or you know, or probably worse. I should probably end this video right now and show you the next step of the video. But this proof of concept shows that you can connect multiple solar panels of different brands, of different types, to different solar charge controllers, and it will work fine. And you could probably use a 200-watt solar panel. Like the example would be here, in that on a hazy day, a 200-watt solar panel might produce only 50, but you know, this, yeah, so I gotta run. It's raining. So here's a proof of concept that you could charge it and discharge it at the same time. They call it on solar generators fast-through charging, but it's a bit of a misnomer. Technically, using a battery bank, you could directly power something from the sun or from Dell 240-watt power brick. So right now, what I have is my window fan running off this guy through an inverter that's connected via this wire. So that's very simple. I have a fan that's probably 30 watts. In total, right now I'm using 92 watts. So that's a couple windows fan and a ceiling fan, and the laptop you see is charging at 25 watts using this, the power delivery. This little adapter over here takes the Lenovo port and does a power delivery trigger to say I want 20 volts to the USB-C power delivery system. So let's just pretend that constant loads, you want your internet, your computer, let's say your computer and your cooling system working all the time from it, right? The sun was off, but now the sun turns on. I have this little timer here, and that turns on the power bricks on the end. The fan continues. This guy continues to go, but now you have wattage coming in to the solar charge controller, the MPPT, 9.7 amps, 9.4 amps. The way that these work, if I understand it correctly, is these things, they gauge the voltage of the battery bank. The example being is that at a certain voltage, it's at 50%, at a certain voltage, it's at 70% or 90 or 100%. Over here is an example of an extension cord. This is one 45 amp Anderson connector spliced together, two wires that are 14 AWG that can both do 15 amps each. And what this shows is that you can have also the splitting of this port quite easily. Let's say you need more expandability, and these you could do yourself. You know, I taped this up myself. Having done many of them, I found it to be very comfortable and very fun actually to do, because you're designing your own systems and it's plug and play. Standard systems where you're plugging directly to over here to the terminals, they take up too much space, they're inconvenient, and they're not as plug and play as this. So for example, with these charge controllers, the way that I have it set up is that I can come home, and if I want to, charge from the Dell power bricks that are on the wall back there behind this other battery bank. So yeah, I've been kind of busy. I have also a 70 amp Victron controller, but I'm finding that I like charging with these better, because I find that even using 3 wires, it gets hot because it's so many amps from one controller. I prefer spreading the ampage over these devices together. So now you will see that it's actually bringing in 336 watts positive. So it's kind of like, remember it was 98 it was using? You have 4 controllers at, let's say, 120 watts each. That would be 480. So basically the way it works, the way that electrical systems work, is the electricity that has the highest voltage is going to be used up first. How these things charge the battery is they send a 14.2 volt, you would see on the back here, see 14.2, 14.4, 14.4 volt signal to this battery. You don't want to overvolt it because that would probably damage it, but the point is this, is that it's going to keep charging 14.4 volts, and then once it reaches that voltage, it's going to settle out maybe at 13.8 fully charged. Don't hold me to those numbers, but that's basically how it works. But because this solar charge controller has a 14.4 voltage, and the battery voltage over here, where's the voltage meter here? And the battery voltage is only at 12.7 volts, that means that the 14.4 volts is actually going directly to the laptop and the window fans that I have over here. I find this very convenient. One of the other reasons that I like this setup better is because I find that connecting stuff to my Oukitel or other solar generators that's over a couple amps, they start turning on their fans, they start making like electrical coil whine noises, which I prefer not to have. I just want to have quiet electronics. And using a system like this with multiple solar charge controllers that I could use with a solar panel, because basically put this from the power brick, from the Dell power brick, which I had to adapt to the Anderson, obviously, you get a multimeter and make sure the red is the plus and the other one is a minus. Inside is usually a wire that's kind of a white one and a black one. The white one is usually positive. It's pretty easy to tell, but then when you put the Anderson connector on, put the multimeter in the holes and make sure it says, you know, the positive voltage of 19.5 volts rather than minus. If it's reversed, it would say minus on the multimeter. So what I like about this system is I could run my window fan, let's say my laptop, for a long time, and it will eventually, it could run out, and then I could quickly disconnect this and plug in, let's say, one of my other batteries, this other battery that I put to a cart and have that bigger charge controller. The idea of that bigger one is that I can connect 400 watt panels to it. Because it's 70 amps, it could do up to a kilowatt of energy. So you could put 400 watt panels and connect that to that charging bank. But right now I'm just using these separate charge controls because I find them easy and convenient, and that's what I prefer. And so I've done this to all my battery packs here, and I find that this is revolutionary because it's a safe way to use electricity. 12 volts can't hurt you. I mean, you could try, but please seek help then if you need that, if you wanted to. Anyways, the point is this: 12 volts is safe, especially with car fuses. Like, the idea is we're incorporating car and marine design in together with the Anderson ports, which is to me an easy port to use. You can't reverse it. It's a plus to a minus. Let's say if I tried to doing the minus to the plus connector, it wouldn't connect. It's a universal connector. I can connect to charge, to discharge. I could connect adapters splitting it. And another point with the amperes. So this is 10 AWG wire here. Two 14 AWG cables can barely fit into a 45 amp connector from Anderson. So that's how you can combine them. But now this 14 AWG cable can only do 15 amps. But we have these controllers that could do maximum of 10 amps, so I'm not overamping it. With electricity, we have to be careful not to overamp it. Technically these wires could do unlimited ampage, but doesn't mean that the jacket won't burn off if you did. Let's say if you put 1,000 amps through this wire, it might catch like it's gonna go like the coil inside the light bulb. It would light up. Eventually the jacket would burn off and then you would have an issue. So that's the idea with this, because this won't allow more than 40 amps. So if there's a short circuit, other people that created for, let's say, van life, RVs and all these other things, their systems, they're so complicated and have these wires that anyways, it's too centralized. I like this system much better. These guys made a much better controller, battery of power. I give them a lot of thanks. You see this coming from the charger brick, and it's simulating a 240 watt solar panel. So what I'm trying to say is this, is that if you connected a 200 watt panel, that out of that 200 watts, you would only get 122. But if you connected a 100 watt or 120 watt panel, you could get the full wattage out of it to the solar bank, because that is how it works. But then if you think about it, a lot of time, let's say in the morning time, when you have a hazy day, as we've seen earlier, in the haze, it produces a lot less, but it still doesn't produce zero. So even if you connected it over panel, then connected 200 watts of panels to it in parallel, you would have this 120 watts, but that would last longer throughout the day, if you know what I mean. I'm doing my best to explain here. So this is what I like about this system. There's no fans. It's easy to plug and unplug things. It's easy to plug in accessories. Let's say I want to plug in my laptop USB-C. There's different adapters that do power delivery. You will find that most laptops actually have 19.5 or 20 volts. The mini PC UM790, it said 19 volts, but with the previous version from them, I was able to do a 20 volt power delivery, no problem, and it worked fine through the barrel plug. So I recommend everybody learn how to use these, and perhaps I will link you to the video of how to do that. This is Testa tape. There's two different versions. There's one that's fuzzy one, that's kind of like a fleece one, and there's more of a smooth one. I like both, to be honest. But the reason why I put the Testa tape is that these kind of slide into each other, and I don't want them to slide off. There's also little connector plugs, which is kind of like a bridge you plug into here and plug it into the device that you have connected. You see over here, between here, and it can hold this connection from disconnecting. So that's another powerful part of this system. So the proof of concept is this. You can connect 200 watt solar panels, 100 watt solar panels. You could connect power charging bricks. But if you're doing power charging bricks, probably do 180 watt to 240 watts. But I recommend the 240 watt Dell charger bricks because there's a ton of them on eBay for like 20 bucks. I recommend those probably. Yes, you're only gonna get 9.3 volts. This thing gets hot, but it doesn't, it's not like a burning type of hot. It's more like, let's say, like an NVMe SSD kind of hot. That is completely normal with computers and computing. So I find that convenient. And with these Anderson connectors, you see I was able to connect this power meter and show you that, because over here on this meter it says 19.3 volts. You know, it's tough for me to do math in my head being a millennial. 9.2 times 3, I just look at the screen here and it says 121 watts. Isn't that much better? Good job, guys. So long story short, this is the kit that you get, this Powerwerx 301 piece. You see, this one is for the tiniest wire, probably 18 to 14 AWG. This is probably 12 to 14 AWG, and then there's other one that's slightly bigger for the 45 amps. You see? And you see that's the little bridge that's connecting it. And these I've never used, but I got a feeling they could be hammered into that hole that we have there. And some of these are connected like this. This is the more expensive kit, but this is more inclusive. I've went through several of these. I do recommend getting some sort of little poker thing, the tweezer, man. Tweezers, sometimes you want to hold the wire in until it snaps into position inside the housing. You're gonna hear a little snap. But that deserves another video on its own. But overall, I'm happy with this system. Another reason being is that solar generators are pretty expensive, and what I find is that the most efficient way to power your electronics is DC to DC. So, for example, this adapter over here takes 12 to 24 volts DC power right from the bank and converts it to the DC power that you want, depending on the power delivery trigger that is sent to the micro architecture inside this device, inside this power adapter. So it could tell it, I want 20 volts, I want 15 volts, 12 volts, 9 volts, 5 volts. Standard USB is 5 volts. The bottom one is a quick charge up to 18 watts of charging. I don't know what voltage, but the bottom one can maximum do 12 volts. So you can connect to both the top and the bottom one. So the top one you would plug in your laptop that wants the 20 volts, and into the bottom one you would connect a 12 volt device such as your Wi-Fi router or a non-Wi-Fi router, depending on what's your choice, whatever you want to do. But the idea is this, is technically you could connect, let's say, a 12 volt, and that powers your internet modem, and you could always have internet and connection, or your Wi-Fi router, and then the top one could be, or you could do both 12 volts and it could be a modem and a Wi-Fi router, and then the laptop you could just use from the thing, and then you could connect other devices and so on and so forth. You could connect multiple solar panels into it. You could switch up these banks very easily. What have you seen other people with battery banks where they could switch it up this easily? You just saw me have this outside and connect 4 solar panels to it. Now I'm inside and I connected 4 Dell power bricks to it, and I'm charging at 300 something watts and powering my window fans and charging my laptop all at the same time, without a hesitation. But let's say if let's say there's the solar panel went out, or my electricity went out. Let's say I had it connected, so electricity went out, and you see over here now my fan is continuing to move, the laptop is still charging, and now it's doing minus 94 watts. Isn't that convenient? So basically put, it's an uninterruptible power supply. And the reason why I also like the MPPT charge controllers is, my idea with MPPTs is this. They're more designed to be plugged into the battery all the time than a charger is. The charger listings I've seen on Amazon is, they say disconnect the battery after it's charged up, but that's not convenient. You might want to have your thing connected all the time, or you might want to put a little timer switch and put, like, let's say a 6-hour time period for it to charge, so you know it's turned off, and then you're cycling through the battery all the time. And because this has thousands of charge cycles, I find it very convenient to do it. See, now we reconnected it. Now we're doing plus 26 amps. Charging right into this bank. Beautifully charging. It's working great. It's working and powering at the same time. But then just move the system, move back to a higher end view, and think about it like this. A couple 100-watt solar panels outside, or let's say you have a power outage. Your fridge is the most important thing that you want to keep powering. So you could have an inverter connected to it, like I have an inverter here. Mind you, I have a 500 up to 500 watts inverter, but I'm not using that much wattage, so I'm okay with this wire. But then, because I have 2 cables connected to it, I could just run a second cable. So 30 amps and 30 amps, that's 60 amps. It could power it without any issues. What I'm trying to say is this, is that you could split the load coming out of it, let's say over 2 wires. That's not an issue too. Let's say you need more amps going somewhere. But you're gonna notice that most laptops are 100 to 200 watts. Fans are 50 watts, 20 watts, 30 watts. Electrical lighting, 20 watts, 30 watts. So you could have a battery bank like this to last a long time and keep you powered up. And you could plug it, replug it, unplug it, change it up, take it outside, solar charge it inside with your power bricks, and just have a great time doing it. So that's my complete dissertation of this. I will provide links below to the different items I bought to make this work. Please put a comment below if you want me to make a tutorial guide on how to make these connectors. Because if we are able to make these connectors, the battery by itself is quite cheap. Now we have an unlimited power supply battery pack situation going on, and why not do that? Another thing that I'm also thinking is, technically you could use this one to charge a solar generator that does maybe up to 100 watts. That could be your inverter and USB charger. Let's say you left this outside to charge up for a while. Maybe through this power delivery port, you could just plug in the solar generator, the 100-watt one, the one that can only do 100 watts, and you could charge that up from fully and then put this outside the next day to charge up again. The options are infinite. And I hope you guys can appreciate this and understand this, because what you're gonna see with the other videos, the other way people do battery banks, it's so complicated. Everything is centralized, everything is hardwired. But with electrical devices, I mean with computers, I can change a wire around 20 billion different times as I'm testing it to see what works well. And you never know, and I just find this very convenient. Little tiny 130 watt chargers that are small, fit in the palm of your hand. I just love the way the system. Also, I bought this battery bank to take it outside because it's smaller than my other metal ones, and it was on sale. You know, when you see something is good, I think I was able to get this for 260, 100 watt hours. But I still find that what was it? You know, the 150 amp hour battery, cloud power, much better. What was it? Cloud power? I think Cloudenergy. Yeah, the Cloudenergy 150 amp hour battery is the ideal one because it's almost the same size, and it's like, instead of 1.2 kilowatts, it's like 1.9. So you get a lot more wattage out of that. So I'm picturing a world where people could get a battery like this, connect a couple 100-watt solar panels, and their electrical needs are met. I mean, nowadays you could do pretty much anything off the laptop. You could run a TV probably with 100 watts connected through an inverter, get a Victron, because those are the best. And they have different types of wattages. A gaming PC is tougher, but you could probably power it off just an Oukitel. Just get an Oukitel, big one, if you want to have a gaming 4090, 3090 PC. But otherwise, we could all live off solar power technically using systems like this, and this is much more easy plug and play. You know, I feel comfortable letting kids and dogs and animals and chickens and goats and anything, probably not a goat, because the goat is probably going to chew through these wires and get shocked, but you probably can't get shocked because it's 12 volts. When you get a 48 volt system, that's probably a little bit tougher, but overall, proof of concept, power bricks. You could put them on the wall down there. You see they're just hung up on the wall. It's convenient, it's powerful. You could use universal power supplies, power pretty much anything. Most devices are DC nowadays, and you could use your AC power to charge your banks. You could have multiple banks, and you see that down there, I have another one. And I absolutely love it. So thumb it up, guys. Check out the descriptions, check out my other videos, and let's have a discussion. And let's have also not just a discussion, let's have a technological revolution. And if you guys do something like this, post links below, or if you find something interesting, share it with others. Others might want to see it, and we could use YouTube University to help each other out and build a new life for us, and get these you know, if everybody stops using these guys talk about all this carbon and all this stuff. I don't believe in that carbon stuff, but I don't want to burn things into the environment and breathe that in later. That's what I don't want. I'm not worried about the carbon because I know plants breathe it, and I exhale it, and it's a scam to get money to sponsor people to do stupid stuff with this money. You know, it's basically a tax on life itself. You know, can you imagine this? You have to be really evil to want to do that. But I do want to have clean air and have clean water, and you have a battery bank that could do thousands of charges. So probably 2,000-3,000 charges before it gets to 80% capacity. At 80% capacity, we're talking about 700-800 watts. You just plug in an extra bank, and that would be, if I uncharge it and discharge it, what? That's 10 years of everyday charge and discharge on this one battery bank. But then if you have many of them and you don't discharge them fully, we're talking about decades. Maybe in 100 years from now, somebody might find this video and say, wow, these guys finally figured it out, and thanks for saving the environment and the planet. And then my future generation kids would be happy to be enjoying it, and to be enjoying the freedom of not having to pay for every single watt they use as many watts as they want, by building systems and understanding, and that are safe and compatible and working. But anyways, thumbs up, guys, and have a great day. I will see you in the next one.